Hello and welcome everyone to my presentation about our paper that is entitled Comparing and Combining Test Case Selection and Prioritization Towards Regression Test Orchestration. My name is Renan Greca. I'm from the Gran Sasso Science Institute in Italy, and my co-authors were Breno Miranda, Antonio Bertolino, and Milos Gligoric. So today I'm going to start off with a brief introduction to regression testing, focusing primarily on the challenges of test case selection and test case prioritization. Then I'll explain how we did this test suite orchestration with a tool called FASTazi. Then I'll show a little bit of how our experiments were done and what results we got from it. And finally, give our conclusions and what are the next steps in our work. So first, regarding regression testing, it is an activity which the primary goal is to make sure that things continue to work after changes have been made to a certain system. So when software is already designed to perform a certain task or has a certain feature, sometimes when a new feature is introduced or when a bug is fixed, it can happen that a previous bug is reintroduced, or a bug that didn't exist before starts happening on a piece of software that used to work fine before. So regression testing is the activity that you make to ensure that have some guarantee that if something is working, it will continue to work, and if it doesn't, the developers will know about it and will be able to fix it. So regression tests, what happens with regression testing is that sometimes over the years, as the software is developed for a long time, the number of tests on a regression test suite turns out to be too big, and it takes a very long time to run all the tests, and it's not really feasible to do it after every modification to the program. So test case selection comes to help with this. Instead of running the entire test suite every time, we can select a subset of test cases that somehow represent the entire test suite by some criteria. Often it is based on the model, so it will select test cases that on the model have something related to a part of the program that you want to test. Or it can be change-based, which will select tests based on which of them are related somehow to changes that have been made to the program since the last version. And what you want to optimize there, you want to select a relatively small percentage of the test suite, and you want to do that while still maintaining, still detecting failures if they happen. And of course, ultimately the objective is to reduce the time that it takes to test the program after each change. So here we have a quick illustration of how it works. So let's say we have a test suite with 10 tests, and in this particular instance, if we run the suite, test 7 will fail, will give us an error. Sorry, not an error, a failure. And we want a smaller test suite of, let's say, 6 tests, so a 60% selection. And we want test 7 to still be there because it's the one that is at this point the most important one that will give information to the developer about a possible bug that is happening. And by doing this, we have run fewer tests and we still detect that failure when it happens. For our purposes, we have used a tool called Ekstazi, which is a change-based test selection tool. And it uses file level granularity. So what it means is that whenever any file, any source code file is changed, it will select all tests that have to do with that source code file somehow. Like even if they're not, even if you change a very small part of the file, anything that has to do with any part of that file will be selected. The disadvantage of that is that you have the potential of selecting more tests than a finer tool. But the advantage is that it takes less time to do so, and depending on your test suite, it can be faster to select more tests and run them than to spend a lot of time carefully selecting each test case. We have here a few links if you're interested to know more about the tool and also the paper where it originated from. The next challenge that we discuss is test case prioritization, which is not to reduce the size of the test suite, but to reorder it, rearrange it in a way that if there is a relevant test that is somehow likely to fail, we want it to be near the top of the test suite and not in the middle or the end. So the goal there is, even if we do run all the tests again, we want the notification that a failure happened to be earlier. So it takes less time for a developer to find out, okay, there is something to be investigated here, and get to work on fixing it. The goal, so it can be coverage based, for example. There are tools that want to maximize the coverage in the very first few tests, or it can be similarity based, which are test tools that make sure that there's some diversity among the first few test cases in the suite, and we don't want to run very similar test cases in a sequence, because there is a high probability that similar test cases will cover similar parts of the code and reveal similar bugs if they exist. And the main metric there, the one that is most widely accepted by the literature, is called APFT, which means average percentage of faults detected. And it's basically a measure of, given two different prioritizations of the suite, which one is likely to reveal all existing failures sooner than the other. And of course, the prioritization time, which is the amount of time it takes to actually generate a prioritization. So here we have another illustration. So we have again the same test suite, and we want to prioritize it. So we still maintain the same test cases, same 10 test cases, but in this case it's rearranged in a way that test 7, which is the failing test in this case, is at position 5 now. So it's going to be detected a bit sooner than it would have been in the normal test suite. And the tool we are using for that is called FAST. It's a similarity-based approach. So again, it has to do with getting a diversity of test cases. And it has two modes. Either it can be based on the similarity of the coverage that each test case achieves, or it can use a combination of big data techniques such as Shingleman hashing and locality-sensitive hashing on the string representation of the test case, and finds a notion of similarity based of that. And the focus of this tool is efficiency and scalability, so it actually runs quite fast. It has the slowest part is actually generating these hashes before the prioritization, and then the prioritization itself is very efficient and scales very well to very large test suites. And again, I have have the link here to the original replication package of this tool and the paper where it comes from. So what is test suite orchestration? It is an idea that we have that, okay, test selection is good and test prioritization is also good. It can help find failures faster. It can help reduce the total testing time. But it can be beneficial, probably, to put all these things together and potentially even more techniques beyond selection and prioritization. But for now, we're focusing on these two. And we want to find out what are the advantages and what are the drawbacks of running two techniques that were originally not designed to be used together. The Ekstazi and FAST, for example, they had no idea that the other one existed when they were developed, so what benefits can we draw if we do use them together, and what are the challenges involved in that? So basically, yes, what we want to know is that, okay, different solutions being put together will generate a complete strategy that can be used in a software that is always evolving, and possibly even in every change to the program, in order to optimize the execution of the tests. So I'm also going to illustrate this in a similar way. The simple approach that we start with is just combining the two in sequence. So first we have the test suite, then we select a certain number of tests, and then we prioritize that same selection of tests. So ultimately we have a test suite that is smaller and rearranged in a way that a failing test will be detected much sooner than it would have been in the normal test suite. So for example, here in this example, the test case was on position 7, and then it's now in position 3. So it's about half. It would take half the time to get to it, assuming unit tests that tests take more or less around the same time to run. So I have a diagram here to illustrate how we performed this. So SUT is system under test. It's the program that is being analyzed. And since this is an interesting peculiarity, because since Ekstazi and FAST, they don't know about each other, we can actually run some of their tasks in parallel of each other without waiting for a dependency. So what happens is on one thread we can compile the program and run the test case selection with Ekstazi, which requires the program to be compiled beforehand. And on the other hand, we can generate those hashes for FAST, which do not require the compiled program, since they are run actually on the raw source code of the tests. So since that is the slowest part of FAST, and keep in mind it's not extremely slow, it's just the slowest part of that program, and it's still much faster than compiling. So while it compiles, we can generate those hashes. By the time the program is compiled and the test cases are selected by Ekstazi, we already have those hashes done. And then finally, we just need to give the selected test suite to FAST, and it will rearrange the tests in a way that according to the tool's criteria. Alternatively, we can prioritize the tests first and pick out the ones that have been selected, so prioritize the entire suite. And we have tried that as well, but in our experiments, the results were very nearly identical. So we prefer to go with this route, which is a bit simpler. So to show a little bit of the results we got, first, this is a metric that we used that is called test still first failure, which is how many tests were executed before we reached one that failed. And we can see here we have a violin plot for each of the competitors. If we run Ekstazi by itself and FAST by itself, or FAST by itself, there is an interesting phenomenon that the median is very similar in both cases, but as you can see, Ekstazi's distribution is closer to the median, and FAST is more spread out evenly between 0 and 100% of the test suite. And Fastazi, if putting them together, what we get is something that is the density of the violin goes to the bottom, so we have 50% of the test situations that we tested were found under 25%, more or less. But then, unfortunately, there are a few instances, much less than by FAST itself, but there are a few instances where both tools don't perform very well. In Ekstazi might select very close to 100% of the test suite, and FAST by the nature of similarity-based, it might prioritize the desired test near the end of the test suite, and then when both of those things combine, Fastazi also has a poor performance. But still, on the median case, and statistically we have shown that in the paper, that Fastazi is more reliable than Ekstazi or FAST alone, and in the majority of cases it will find the test sooner. And we also compared it with random as a baseline, just to see like, okay, but we know that in random the things tend to get closer to the middle. And then the main drawback that we were concerned with was knowing whether this would incur further costs, would make the testing process slower, or the overhead before testing slower. And we found that it's not actually the case. So we ran the experiments with 12 open source tools and several versions of each one. And we have here a chart that shows the time that it took for each step of the experiment to run. And the gray bar, which is by far the largest one, is the compilation time. And then we see the smaller ones there, that fast, it has the 2 steps, one which is to prepare the hashes, one is to actually prioritize. And always preparing the hashes is slower than the prioritization. And then we have Ekstazi, which is the selection step that happens after the compilation. In a few cases, it's similar to the compilation, but in most cases, it's much less than that. And then Fastazi would just be the time it takes for Ekstazi to run, plus the time that it just fast just takes to prioritize the selected test. So compared to only running test case selection, the additional overhead of also prioritizing is extremely small. And our conclusion from that is if your test suite is already in the situation where test case selection would provide a benefit to it, and you are willing to accept the cost of selecting, doing prioritization in addition to that is an extremely small cost and provides much more benefits than drawbacks. So as a final recap of what we have said today, our conclusion is that it is possible to combine test case selection and test case prioritization with a very negligible increase to the overhead. And this combined solution, it will detect failures using fewer tests in general. So it will detect the failures faster, and you can run fewer tests. You can get the feedback for the developer sooner. And it's important to note that we have used Ekstazi and FAST as a proof of concept of this idea, and they are representative of test case selection and prioritization, but they're far from the only tools that exist for that. And our understanding is that this concept can be applied to different tools. It's just that we use these two because they were available to us, and they had the implementation done, and they worked well. We have a replication package with the URL, so feel free to access it, download the file, see the source code, run some experiments, and see it for yourself. And finally, the next steps of our work is to experiment with subjects that are less controlled. We have used for these experiments a data set called defects4j, which curates the failures somehow, and the next step is to run it on an open source project that has no curation, just as it is. And after that, we also want to include other kinds of regression testing challenges, such as amplification and reduction of test cases to maybe increase the size of the test suite with new tests, and then reduce it to eliminate redundant tests. And the end game is to make orchestration into a plug-and-play approach, to make sure that what we desire is that researchers and developers who create these tools for different regression testing challenges do it in a way that they can easily work together. They have similar formats and conventions, in a way that someone who is interested in using all of them together can actually put them all in a program, and they can work. And that is it for today. Thank you so much for watching, and have a nice day.